Okay, chapter 15, random variables. So the idea in this chapter is looking at items, variables, that can have different outcomes. And these outcomes, remember, they are random. Like we've seen in other things where you're collecting information saying, hey, well, what's the tendency here? I understand these values can be different, right, from one outcome to the next. So as we're looking at these random variables, we do want to understand their behavior some. For instance, what's the most common value? What's the expected value that we might have? Also, we want to understand things like what would the standard deviation be, what would the variance be, just like typical, right, so that we can start to understand very well what the balance of outcomes might be on some distribution. So for the first part, we're actually going to look at individual variables, things like what is an expected grade or what is an expected amount of money to win in this card game, right? So outcomes when we're just dealing with one variable. And we're going to talk about ways to quantify that when we're looking simply at the outcome multiplied by some probability. And then we're going to go into a phase 2 of this video where we begin either shifting these values around. If you think about maybe the random variable being amount of payout at for 16-year-olds, right, that you have insured at your insurance company. If the payout amount is the random variable, we might say, you know what, well, now things are more expensive. Instead of just analyzing what the average payout would be in that variance or that standard deviation for each 16-year-old, what we're expecting that to be, maybe I want to say, hey, well, the amount of money's gone up, so now everything should shift up to respond, right, if all of the costs have gone up also. So we're going to talk in phase 2 about those types of shifts. And then in phase 2, that second video for this, we will also talk about taking two separate variables, two separate random variables, and combining those in different ways. So for example, back to the example of an insurance company, if I have a group of 16-year-olds, right, that I'm looking at as my insured drivers, and then I have a group of maybe 58-year-olds that are my insured drivers, they may have different tendencies, right, different payout values as the typical occurrences for their driving habits. So as I'm looking at this variable, I'll call the 16-year-olds X and the 58-year-olds Y. As I'm looking at these two different groups, if I put them together, now I have a combined expected value for the two groups, right? And a combined standard deviation or variance for the two groups. So again, that will be phase 2 of this. So those of you who are business majors, insurance types especially, this lesson I think will be especially valuable for you. Just understand that we have to get there first. Initially, we're going to focus on one variable, and then by the end of this chapter, we're going to be focusing on multiple random variables combined together. Okay, so let's begin with a kind of basic example. This is following the class notes that I have posted for you now in As You Learn. So as you click on those folders, you can find PDFs that go along with these notes to help you also. This first example is example 15.1, and it's talking about quiz grades. So it reads, if you want to pull this up, it may help you, but I'll read and take some shorthand notes with you. We are going to have a 4-question quiz throughout the semester. Well, 4-question quizzes throughout the semester. If you have a 90% knowledge of the material, what average score do you expect to earn? So, if we have 4-question quizzes, and we know that our knowledge is at 90%, let's consider the random variable being our grade, right? That's the thing that can vary from one quiz to the next. So the question here is, what average score do you expect to earn? And the random variable that we are looking at here is that score, that item that can vary randomly. Okay, well, maybe initially it's maybe the 90% is something you notice initially, right? You're saying, hey, well, if I know 90%, wouldn't I expect to score about a 90? And if that's your intuition beginning this problem already, you're absolutely right. So the first definition that I would like to write out for you is the idea of an expected value. Which is almost intuitive, I think. The expected value, just like in this case, that person having or you having 90% knowledge, you would expect to get about a 90. Expected value can be notated E of X. This represents expected value of variable X. So here we're calling our random variable score. We're saying that random variable X is going to represent score. Okay? And this is equal to our mean, or mu. So in this case, the expected value of our test scores is equal to 90. Okay? But then maybe the next intuitive question would be, okay, well, I understand this is what's expected. I mean, that was told to us in the actual question, right? But how much do my grades vary? How much are they changing? Can I talk about the variance and or the standard deviation? So some more notation for you. Variance of some random variable X. It's still referencing the same thing you're familiar with from the past. Remember, we would say something like this. Sigma squared. Now, if I put a little sub x on it, that's just reiterating the fact that, hey, we are still talking about test score, which I'm calling an x. Okay, so that's just another way of reiterating the same thing. There's my variance. And standard deviation, as far as notation is concerned, then we'll actually solve for these values in this context, would be often notated SD of x, okay, in these formulas that we're about to learn about later. And of course, that would be similar to the sigma that you've seen in the past, right? Which you may remember that that's the same thing. Standard deviation is the same thing as the square root of variance. That's the relationship that they have between each other. Again, some of these notes right here that I recommend you take, they may not seem quite as useful yet, but for part 2 of this lesson, I think you'll appreciate them a little bit more when we start using some of those abbreviations. Okay, so, well, I mean, how am I going to figure out these items? I guess based on what you all know so far, there are ways in StatCrunch to do this that I'll teach you later on this semester, but based on the knowledge that I think you would have at this moment, maybe the easiest point of reference would be a tree diagram. Maybe using the tree diagram could help us talk about things such as the different outcomes and how likely we think those outcomes would be. And the reason I'm kind of directing you this way is because there are some formulas that we're going to use in a moment in order to solve for things like our variance and things like our standard deviation. But first of all, here, let me actually give you another formula for this expected value in the case that we didn't already know this ahead of time. Okay, so here are some formulas that you may want to add to your notes for sure. Mu is equal to the sum of x multiplied by the probability of some outcome. This is going to look horrible here, but I'm going to put the probability of x, my test score, being equal to some value. So I know that looks actually not so pretty for probably most of you, but what this is saying is take the outcome, multiply it by the probability of that outcome, and then add those things up. I'll demonstrate those for you in just a moment, okay? And then the formula for variance. The variance of x, or whatever, the test score in this instance, will be equal to, and this is actually quite similar, right? Because remember that with variance we are looking at the squared distances from the mean. So we're actually saying, okay, well, that outcome, how far away is it from the mean? Squared. So we're actually taking that amount, that squared distance, and then we're multiplying it by the probability that that outcome had occurred. So very similar to what you saw up here for the mu, but this time, of course, you're maybe considering the idea of what is variance, looking at those deviations. and taking those squared deviations and multiplying them by the likelihood. This is actually quite similar to something called a weighted average. If you've ever had a class, probably most of your classes, where they use percentages to calculate your final grade for the semester, and they say, hey, what's your grade in this category? Multiply it by the percent in that category. Hey, look, I have an 80 on my quizzes, and they're worth 20%, so I will multiply 80 times 20%, plus what I got in the next category times that percent, plus the next category times that percent. These are basically weighted averages. We have one for the expected value, we have one here for the variance. And we know that if we can get variance, we can very easily also get standard deviation. Okay, so now for the fun part, right? Now for figuring out the different outcomes and the probability of those outcomes, because all we know so far is the expected value. They kind of gave us something in a different direction here. So, tree diagram. And actually, before I get into the tree diagram too much, I do want to show you that there is another place in our As You Learn class that you may find helpful to you. So let me go over here for just a moment to your class in As You Learn. Now, right now, I'm already in the folder. Let me back up a step so that you can see. I'm already in the folder for Chapter 15. So when you're coming in here, notice that I have these modules set up for you. Okay, each module has a folder, and within the folder are class notes and other resources that pertain to that chapter. Chapter 14 is the exception because I put the video up here since it was pre-spring break. So here for Chapter 15, one resource that you may like, in addition to the notes right here that you have as a PDF that I'm actually working through with you, is this Excel sheet, which I think I already have it opened. Yes, I do. Okay. This Excel sheet I think will make your life pretty nice if you would like to supplement. I know in class I don't tend to use a lot of these. I've just mentioned that they're there for you. In this particular chapter, though, you may find it helpful. Let me see if I can make this move. Okay, so notice here along the tabs we have some of the different examples that we're going to be working out, and items are already keyed in for us. You know, what's the outcome, what's the probability of that outcome, and then the formulas are used to calculate the appropriate expected value and variance. So this may be something you appreciate. This is not where I'm stopping here today, but you may like it. It may make your life a little easier. So for example, on this quiz question, we have 90% as the base of knowledge. We see the outcome scores already in this nice table over here, and we have the corresponding probabilities magically calculated for us. That's beautiful. And even the formula that we just talked about right there. Look at that. How nice is that? Okay. But again, I would like to torture you all a little bit more, my lovely students, to make sure you understand, you know, how would I know these probabilities given what I've been given? And again, there is also a way to do this in StatCrunch, but we're not ready for it. I'll teach you that a little later. So for right now, the most recent piece of knowledge that you've got would be tree diagrams. Let's use that knowledge. Okay, so a quick sketch of a tree diagram. Let's take a look. And I know I've got expected value as a whole number there. You all probably won't like this. I'm going to use decimals on my tree because it just makes me happier. I mean, I'll just convert back to percent. Since this right here was a percent right here, I'll convert back to that at the end. Okay, so we have this idea of taking some 4-question quiz, right? And on the quiz, we're going to say, okay, well, there's the first question. And what was the outcome for the first question? Well, the first question is either going to be, I'll use R for right and W for wrong. It's got to be right or wrong. Okay, well, if I know 90% of the material, then what's the probability that I got the question right? 90% chance, right? And there should be about a 10% chance that I would have missed that first question. That's question 1. Remember how trees work, where we're going down. I like to go vertical, but whichever way you're branching these things out, every tier represents another level or another item. So this first tier right here, that's question 1. For question 2, let me make another tier, right? Because things are happening in sequence. So first, there's the option of maybe you got that question right. then what would happen? And then here we have the over here for the, if you had gotten it wrong, there's a two branches up under that to show what the other outcomes could be from there. So let's see. If you were sitting here and you had gotten that question right, what's the likelihood that question number 2 is right also? Well, there's a 90% chance. What about the probability that that question is wrong after the first one was right? There's still a 10% chance, right? And over here, same thing, and after the wrong, we're going to have 90% likelihood of correct or right, 10% likelihood of wrong. Question 3, this is my third tier down. Again, this is how the trees kind of play a little bit. Right, wrong. 90%, 10%. Right, wrong. Trees are nice for concept purposes, but sometimes you'll maybe realize they take a little too long. Such as for your test, you probably don't want to make trees on all your test problems. So by that time, you should have faster methods for doing a lot of this. But for right now, these are lovely, I think, for helping us to see what's going on. How many questions so far? We have 3. Okay, one more question. Oh man, good thing it's only 4 questions long, or we might be stuck having to think about patterns or use some other type of distribution that we haven't talked about yet in this class. I don't think we have talked about at least discrete variables, which is what we're assuming this is, that you can only get an answer right or wrong. There's no in between. So the way we're drawing this tree is that you're either all right or all wrong. And there's 2 outcomes on this, right? Okay. Do I have to keep doing this? I guess I do. I should have pre-drawn some of this. It's getting too small for me to even see it. Okay, I'm not drawing all of it. I can't handle it. We'll just say it keeps going as we do the math. If we decide to go through all of those, we can just imagine. Okay, and here's the right, wrong, at least for the last one, since it's going to be a pretty one. Okay, so let's see. Maybe we'll actually see a pattern pretty quickly on this. So as far as the outcomes, I guess for the scores that we could have on a 4-question quiz, I'm going up here to the top of the sheet real quick just to kind of notate the different scores. If you miss all 4, you have a score. The outcome for that random variable would be a 0 if you miss all of the questions. I'm going to say that they're all equally weighted, of course, and you're getting full credit, yes or no. If you only got 1 question right, well, I guess you have a 25. Half the questions right, you have a 50. If you get 3 of the 4 questions right, you have a 75, and if you get all of the questions right, you now have a 100. So that's the outcomes that are possible for my random variable. So let's take a look here using the tree. And I bet, actually, if you didn't already pick up on this pattern before as you were going through chapter 14, I bet you're going to see a pattern that you're going to like pretty quickly. Even without me having to go too much into the why, the pattern should stand out pretty nicely for you. So let's see. Let's make a nice little table here really quickly. Not with the eraser. Okay. And this right here is going to be my random variable score. I'll put an X over that since that's the notation that we've used, right? And the outcomes for score, we already said, those include 0, 25, 50, 75, 100. Okay? And then the probability. Okay, well, what's the probability that I get them all wrong? You know, I'm looking at a given quiz. What's the likelihood that I get all incorrect answers? Let's see. Let's use we'll say red. The pink is like red. It's like bad. Or wrong, 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 wrong. There's my path of all wrong. Now remember, what we're essentially saying here is first question wrong, and next question wrong, and next question wrong, and next question wrong. Also, there's some assumptions in the back of this, right? Like, for instance, even though I have some base knowledge of 90%, if I miss the first question, I'm keeping it completely independent of the next question, right? So I'm not saying, hey, the percents are changing with each thing that occurs. So because of that, that's why this tree diagram was so easy for us to draw, and that's why the pattern is going to be easy to identify. I can actually just multiply these things because they are independent of each other. the first question being right or wrong should not technically affect the second question being right or wrong. All right? I mean, well, I say technically, but we're just making that assumption that the test is structured with independent questions. Okay. All right, so all wrong, what is that? I guess I'll write out what it would look like first, because maybe you'll appreciate that more. Okay. And of course, remember that we'll have to convert these all back to percentages in just a moment. I keep putting the wrong thing in my calculator for some reason. Okay. Why did I even use my calculator? I don't know. 1, 2, 3, 4. Okay. Very not likely that we're getting a 0. That's good, since I guess we had a comprehension level of an A. That makes me feel pretty happy. Okay. Oh, well, I guess we'll look at the 25. And let's see, to get a 25, that's any way that we only got exactly one correct. Okay, let's look at these different paths that have exactly one correct. I'm going to use green. So, let's see. I could go this way. Doop-de-doop. Only one correct. Okay, well, this one could be the correct one, right? Oh, wait, that one's already correct. If I'm doing the first one right here correct, then I have to take an all wrong path. That helps take off half that tree. Look at that. I should take off that. That wasn't green right there. Okay. I love the pictures. I hope you guys do too. Okay, there's one little path. Right here. Exactly one thing right, one question right, the rest are wrong. Okay, well that's one of a few ways, I suppose. Let's keep going. And then we'll talk about how to get these scores, or we'll do a reminder. Hopefully you figured out already how. Okay, another journey would be, well, to be wrong first, okay? And then, well, your right could occur then. After that, every other step is going to be wrong. Okay, so there's one way, there's another way. Let's see, and then another wrong, wrong, right to wrong. There's another journey, right? And then, man, this is awfully tedious. Okay, wrong, 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 right. So I see 4 different journeys. I put check marks each one. I showed them the sketch. 4 different journeys that get me to exactly one correct answer and 3 wrong ones. So let's take a look here. The first journey over here on the left, I'm going to have to kind of write over here in the margin, okay? But first, looking at the one that I have circled in green. Well, that would have been 90% times, how many wrongs we have? This is because it's the right, then and wrong, and wrong, and wrong, all independent, so I can multiply. So that's going to be that multiplied by 3 wrongs. Okay, lovely. And as we collect the branches, what we are essentially saying is we're saying, okay, well, ways that I would qualify to have a score of 25% here would be for me to say, okay, this first path, or this second path, or this third path, or this fourth path, right? And so for this or, the idea is, first of all, you can't do both paths at the same time. These are mutually exclusive, so we can use our lovely addition in the most basic way possible, right? And so what I can do is take each pathway and add them up. So I'll say, okay, there's path 1 plus the next path. Doop-de-doop. Next one, okay. That was, there's 1W, there's a right, another W. I don't know, maybe you see the pattern of 3 W's again. 3 wrongs, right? So, again, the next path will be only 1 right question and 3 wrong ones. We had how many of those? We had 4 of those, I believe, didn't we? So every single time, if you trace down this picture, you will see that this right here is what you're getting. Exactly 1 yes, exactly 3 no's. So you're using the probabilities and you're linking it. And you would have added the branches. So the cleaned up version of this would look like 4 times this right here, which is a very small number. It's in that Excel spreadsheet. I don't have room to write it out, so you guys can maybe deal with not having it. Okay, I mean, I guess it's larger than the other number, but it's still small, the number for 0. Okay, getting a 50%. Okay, well, this is getting, I complain a lot, don't I? Okay, let's see, 50%. So it's going to be 2 rights, 2 wrongs. Maybe you already kind of see that the pattern's probably going to have 90% or 9/10 to the power of 2, right? Multiplied by the 10% chance multiplied to the power of 2. Because again, you'll essentially have 2 correct and 2 wrong on those journeys down. So the question is, how many of those journeys would have that? Well, I don't know. Let's see. I'll take a look. Let me change colors. We'll use blue so we can maybe see it better. Okay, so there's right, wrong, wrong. Okay. There's right, wrong, right. Wait, right, wrong, right, wrong. That's half and half, sorry about that. Right, wrong, wrong, right. 1, 2, 3 on that side. Okay, good. Then over here, wrong, right, wrong. Hopefully there's a right. It'll be right there. Okay, wrong, wrong, right, right. Oh, there's the other way, is there? Let's see. There might be actually. Wrong, wrong. Actually, it'll be on the other side. Because right, wrong, right. There we have it. There it is. Right, and then go back to the wrong again. So there should be 6, I believe. 1, 2, 3, 4, 5, 6. Okay. By the way, I want to emphasize something here. Let me write this before I get distracted. I want you to remember the way we can look at the number of outcomes also. So what I just wrote, it's kind of hard to see, 6 different paths, and each of those paths, the likelihood of getting down one would be 90% squared times 10% squared, and there's 6 of them, so you're multiplying it by 6. So we really could do this for a while, and there is a formula probably in your reading, but again, it's not a huge emphasis here at this point in the class, that shows you actually the pattern for how to know exactly what you've got going on here, what these numbers would be. I wanted to point out, though, and remind you guys number of outcomes, just because I think it's kind of cool to remember the fundamental counting principle. We're not using it so much here, but when you're going down here collecting these branches, right, the total number of outcomes would be the lowest leaves, right? 1, 2, 3, 4, 5, 6, 7, 8. It's kind of hard to see because then I stopped drawing. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, for a really huge tree, we could have sped up that process, right? Because we could have said, okay, well, how many different steps do I have? How many different tiers? And how many options do I have at each tier, right? So another way to know if I've drawn this tree out properly is to say, okay, well, every single question had 2 different outcomes, right or wrong. So I would say, okay, well, question 1 has 2 outcomes times question 2, which also has 2 outcomes, and the next level has 2 outcomes, and the next level has 2 outcomes. So the fundamental counting principle for figuring out the total number of outcomes is simply multiplying the number of choices at each tier as you go out. And you can kind of see that branching effect is its multiplication, right? Okay, so 16, good. I did count all the leaves correctly. Lovely. Okay, so we could continue this here. Let's go now to that Excel sheet. That's why I think it's kind of nice since it's already in there for us. And this is what the things calculate. This is what the probabilities come out to be, okay? So now building from the idea we had a moment ago, well, first of all, we know that if we take that outcome, right, the score, for example, of 0 and multiply it by this first probability that we found together using our tree diagram, we got the same value, remember? Well, 0 times this, that's going to give me 0. Right? And then 25 multiplied by this value right here, that's what we would have gotten for our second outcome's likelihood. When I multiply those two things, okay, yes, we would get this right here. And so on and so forth, right? Now, if I take those, the probability of each of those outcomes being multiplied together with the outcome, that should give me that 90% that we were expecting as the value. Same thing for those differences. I don't expect you guys to do this by hand. At this point, it's getting a little bit too tedious. But just so you have knowledge, this right here would be us taking that outcome, that score of 0, right, and subtracting the expected value of 90, squaring it, and multiplying it by the likelihood that that had happened, which is still, this is all likelihood right there. That's the P of X. Every single time this is P of X, this column here, okay? Okay, and when you add that up, there's your variance. Square root it, there's your square root. Well, I mean your standard deviation when you square root it. Anyway, so some of this was more tedious than what you'll actually be doing, but I just want you to kind of start seeing these formulas and feeling kind of good about what's happening between them. Oh, also I should probably mention that there was a second formula that I did not actually write out. I should go add that back to your notes. A second formula for how to get variance. So notice here it says variance of x is equal to 225, and check, it's also 225. The other formula, instead of taking those deviations multiplied by the probability, a shortcut would be to take those outcomes squared multiplied by the probability. And then you subtract from that the expected value squared. I don't think it shows that part of the formula here, but let me go back to the little notepad where I'm writing, and I'll write that for you in case you decide you need it, or in case you find that you need it. Put it here. Okay, so again, another formula. This one right here is still for variance. It's not standard deviation there. This is still variance. Another way to get this would have been to have taken that summation of each outcome squared multiplied by the likelihood that that outcome happened. That's why it says big X of X, or is equal to X. I'm going to take that, and then I'm going to multiply, or excuse me, then I multiplied those together, and then I'm going to subtract my expected value squared. That's a cleaned up version of the top. Actually, you know, it's a rewritten version of the top. Okay, so now let's move beyond some of this tedious stuff and this conceptual development, and let's move a little quicker, okay? And I'll show you some cool things in StatCrunch as well. So the next example is a card game, and it says here, consider a game where you're paid $0 for a red card, $15 for a spade, $30 for a club, and $50 for an ace of clubs. And then we're asked some of the same questions, right? Things like, what's the expected value, the variance, the standard deviation for the outcome of this game, right? Okay, so in addition to that Excel sheet that you may find very helpful with Chapter 15 to help you get through some of these problems more quickly and focus more on the concept, we have StatCrunch. So let's see. I'm going to put X, my random variable, and by the way, random variable is equal to the amount of money I get, right? And so let's see, if the card is red, that outcome would have given me $0. Okay, $0. That was when it was red. And I guess I don't need to keep putting the dollar sign. I took it away. $15 if I had a spade. $30 was the money outcome for a club. $50 was the money outcome for that ace of clubs. And now I need to figure out, well, what's the probability of that random variable happening, of X, of each item, right? So for example, what's the probability of getting a red, right? Of getting the outcome of $0, which is when you get a red card. How many red cards do we have? That's a fourth of the deck, isn't it? Now StatCrunch is kind of funny. It likes decimals, so I'll put in 0.25 or 2500s like that. Okay, spades. Oh wait, oh, I did it backwards. Man, I don't play cards, remember? Okay, that's half the deck. Half the deck is red. Sorry, you all. I was just making sure you were paying attention to this video. Okay, half the deck is red. Spades, that's the one where it's a suit. So it's a fourth of the deck. We can do this. Huh. Okay. Now, clubs are also a fourth of the deck, except this is kind of tricky here. You know, because there's still, what, 13 of the 52. Let me make sure I have my little card numbers going on right. Yes, 13 of 52 cards would be clubs. However, this is tricky because down here, the ace of clubs, well, that is a club, right? Versus the other clubs. So that's the place where it gets tricky. I think prior to that, just getting a spade or just getting a red card, no one cares. But right here, you got to be one or the other, right? Because that is one of the prerequisites with these random variables. It must be mutually exclusive. You can't be getting two different outcomes at the same time with one thing occurring. You can't get both of those. So let's see. That means instead of 13 clubs, I'll say 12 divided by 52. Right, and took away the ace there, and that's going to give me, I'll go to 4 decimal places. Whoops. Rounding that up to another 7. It's going to be 7, 7. There we go. Okay. And then for that ace of clubs, that's going to be 1 divided by 52. I guess I'll be consistent here and go out to 4 decimal places. So painful to round when you're a math person. Okay. Good. The reason is because technically we know these probabilities should add up to be exactly 100% or a 1 when you're dealing with decimals. And when I'm dealing with StatCrunch and it won't take my fractions for me, it makes me sad because I do not want to know what that exactly adds up to. It might not be exactly 1. But technically it is if I had not rounded. Okay, so here's a little shortcut for you. If you do not want to go through here and multiply those and add them up to get the expected value and then do all those distances also squared times the probability values and add those up, what you can do is you can go in here to calculators and you can use the custom calculator. Now, do not use this thing for actual probabilities. This is only a shortcut I'm showing you for getting the expected value and the standard deviation or the variance, okay? So let's do this. Custom. My original values, well, okay, that's the outcomes. The money's there. The weights, remember I said weighted average? Look at that. That's my probabilities. My percentages there, right? Let's compute. So again, please do not use this picture for any other purposes. It's just a fast way for you to get the mean and the standard deviation. And of course, if you needed to get the variance, you would just square. Let me get back to my screen sharing. You would just square that value. So let's do this really quickly. So what we found here was that my expected value, E of X, if I'm calling X the money, that's $11.63, and my standard deviation is equal to $13.29. Okay, and again, we are not using this for any probabilities down here, okay? Because right, so we just said expected value $11.63, standard deviation $13.29. So what does that mean to you, right? You're going to play cards. You're expecting to get, what, like $11? That's great. $11.63. But how much is that swinging, right? How do we interpret that standard deviation? Let's see. So the average distance from this amount is $13? Wow. Huh. It's a pretty big swing if you ask me, especially if you're allowed to go negative. That'd be a bad day. But I mean, even if they just say 0, you're kind of heading down pretty far. I've gone really for a long time on this. So how about this? I'll let you all try example 15.3. And what I may do is if people have questions, we may throw something like example 15.3 up on Facebook tomorrow as a little mini video, or I'll give you all the opportunity to earn some bonus points on that one. I will give you a hint though on that example. Hint for the next example in your class notes, 15.3. This really does ruin it, kind of. But the hint is it asks you two different questions. First it says, we have these people that are going to have kids, right? How many boys should they expect? If they give you the likelihood of a girl versus a boy, state the random variable and give us distribution. What is the standard deviation of the number of boys they will have? So number of boys being the random variable is the first thing they ask you. Okay, that's my random variable. And then it says, how does this change if the random variable becomes number of children? And so actually, what I want you all to do, and again, don't be afraid to reach out in our Facebook group and let me know, or show me what you're thinking, and I'll help give you some feedback. But I want you all to think about this. I suggest making a tree. I suggest looking at the little things. I think they say things like they're going to keep having kids till they have a girl or 3 kids. Girl or 3. Right? Make some trees. And then what I'd like to see would be, what are those outcomes? How many boys? How many different outcomes? And what are the probabilities of that number of boys? What are the probabilities for that number of children? Right? I look forward to seeing what you all can come up with. That's a little challenging, but once you have that, I think everything else gets pretty easy. Once you create that tree and realize there's two different tables. Okay, I hope things are going well for you.